Hey everyone, Mr. Herc here. Welcome back to another lesson for AP Precalc. Today we're going to be going over 3.6. Let's get right into it. So here's the bell ringer for today. Pause the video if you haven't done this yet, because I am about to go over the answers. So here we have the graph of f of theta is shown above. We want to find these characteristics about the graph. So the first thing is the period, and there's a few ways you can do it. I like looking for key characteristics, so maybe the maximum, perhaps. And here the maximum goes from pi over 4 to 5 pi over 4, and we want to know this distance between them because that's how long it takes for this function to kind of start repeating itself. So here we're going to go 5 pi over 4 minus pi over 4 to get us 4 pi over 4, which is equivalent to just pi. So that should be our period here is just pi. Our amplitude is going to be our distance from the max to the midline or from the midline to the minimum. So here we have a maximum at 30 and we have a minimum at -10. So you might be able to tell this visually, or we could do 30 plus -10 and divide it by 2 to get 10 as our midline here. And then the distance from 30 to +10 is just going to be 20, so that should be our amplitude here, is 20 units. Our midline, as we just found out, is +10, so I'm going to write y equals 10 is our line that is the midline. Our b value, remember our b value is just 2 pi over our period, which in this case is pi, so our b value here is just 2. For two sine starting points, remember our sine starting points are going to be points that are on the midline and going up. So this would be our first one, and then this would be our second one here. And so those two coordinates will be 0, 10, and pi, 10. So those are our two sine starting points. Our two cosine starting points are going to be at the maximum, and they're going to be going down. So here, those 2 points are the ones in blue, and that is going to be pi over 4, 30, and 5 pi over 4, 30. And that should be our answer for our bell ringer there. So previously what we've learned how to do, as we just saw in our bell ringer, is find the period, amplitude, midline, sine and cosine starting points, and then even the b value of a sine or cosine function, both of which are classified as a sinusoidal function. So when we say sinusoidal, we mean it could be either sine or cosine, doesn't just have to be sine. And so we're going to use everything that we learned last class to write equations for these functions. And so it's going to be a lot easier now that we spent a day learning to find all these characteristics than it would have been if I just taught this kind of from scratch. And so our equations are going to be in the following form. It's going to be very similar to like how quadratics were like y equals a x minus h squared plus k. Our equation for the sinusoidal is going to be a, and then it's either going to be sine or cosine, one of the two, b, x or theta. In this case, it should be minus c, and then plus d, or plus c plus d, sorry. And that should be our general like parent equation. And so we'll learn how to find one letter at a time. So let's start off by finding our a value. And our a value is going to be our amplitude, which could be either positive or negative. And now, what does that mean? Well, let's take a look at two graphs that I'm just going to sketch real quick here. The first one is going to be like this, and then the second one is going to be that graph, but reflected over the x-axis. And let's say this is 2, and then this is x there, and then let's say this maximum here is 2, and then -2, 2, and -2 there. This graph right here, if we were to write a sine equation, would be y equals 2 sine of x, right? Because it's just a sine equation with an amplitude of 2, assuming this is, we'll say this is 2 pi as well, just to give it some more context. So that would be the equation. However, what happens if it's flipped and there's no horizontal translation? This would just be y equals -2 sine x here. where it's our regular graph. The amplitude is 2 this time, so that's why there's a 2 out there. But it starts at the center, at the midline, and starts going down instead of going up. This is going to be -2 sine x. And so your amplitude, though, will always be positive, but your a value may be negative. So the amplitude will always be a positive number, so don't worry about that. And the biggest thing is when we get to like write our own equation, I would almost never use a negative a value. But when you're deciding, when you're matching an equation to a possible graph, you may need to know that a negative value will be the same, but then just flipping it over the x-axis there. And so let's take a look here. What is your a value for the sine graph if your starting point was point A? Here, our a value would be positive. So if our starting point was point A, so starting point A, here our a value would be a positive number, and this has an amplitude of 2, so it would be just positive 2. For B, though, if our starting point was B, our a value would be still 2. It has an amplitude of 2, but it's going down. It's starting at the midline going down, so this would be -2. So that's an example of a negative a value in action, even though for both of these both have an amplitude of 2. So example number 1, write the equation of this cosine graph in the form of f of theta equals a cosine theta. And so taking a look here, we're starting at the maximum and we're going down. And this is going from 2, and then the midline here is 0. So from 2 to 0, this has an amplitude of 2, and it's starting at the max going down, so this is going to be a positive a value. If it started at the min and went up, it would be a negative a value there. B, our letter B is very easy. This is just going to be your B value, no matter what. So remember, your B value is just 2 pi over your period, and that is why I had you find your what I called your B value, because that is literally going to be what you plug in for B in these equations. So example number 2, write an equation of this sine graph in the form of f of theta equals sine times b theta. So in this case, what is our period? Let's find that first. So our period here, we go from 0 to pi here. So that's going to be our period, is just going to be pi. And then our b value is going to be 2 pi over our period, which is just 2. So then our graph should be f of theta equals sine and then 2 theta. So that should be our answer for example number 2. Example number 3, write these sine functions in the form a sine b theta. So here where we're adding in our amplitude and our b values. So taking a look at the first one, right? This is f of theta equals a. Our amplitude here is, it's hard to see, but this should be from 3 to 0. So 3 sine, and because it's starting at the midline and going up. And then our b value is going to be our 2 pi over our period. So our period here is from 0 to pi. So then 2 pi over pi is just 2. So this should be 3 sine 2 theta. This next one here is going to be f of theta again, I guess. Our amplitude should be positive 2 sine. And then our period here is going to be pi over 2. It goes from 0 to pi over 2 there. It happens twice in pi. So yeah, so our period is pi over 2. So then 2 pi over pi over 2, remember, is 2 pi over 1 times the reciprocal, 2 over pi. This means our b value should just be 4. So this would be 4 theta is our answer to part B. Part C here, if we take a look, our amplitude is going to be 3 from 3 to 0. So our amplitude is 3. So f of theta equals 3 sine. And then our b value is our period, is going to be pi. It goes from 0 to pi before it starts to repeat. And then 2 pi over pi is just 2. So 3 sine 2 theta is going to be our answer to example 3 as well. So finally, D is going to be our midline. This is going to be a vertical translation of moving the whole function up or down D units, depending on if it's positive or negative. But basically, it's just going to be the numerical value of your midline. So I know in the past you've written like y equals -6 as your midline. That's just like your D value is -6 here. So example number 4, write the equation of these cosine graphs in the form of f of theta equals cosine theta plus d. In this case, our midline is going to fall at -2. So this is going to be, let me erase that, cosine theta minus 2 on the outside. That looks good there. And then for here, for b, our midline is going to be at +1. So this should be f of theta equals cosine theta and then +1 on the outside there. And that's our answer to example number 4. Example number 5, the graph of the sinusoidal function h is shown in the figure above. Find A, B, and D here when we have the amplitude, period, and midline. So let's write this out. H of theta equals A sine theta, or sine, and then B theta, and then plus D. So let's do our amplitude first. Our amplitude here is 6. So we're going to have 6, and then we start at the midline, and we go up. So it's going to be a +6. So that looks good there. Our period is given to us to be pi. So then 2 pi over our period should be giving us our b value of 2. And then our midline is how much we're going to shift the graph up or down. Here we move the entire graph up 3 units. So this is going to be +3. And so a should be 6. So you could either write the equation or a is 6, b is 2, d is 3. And that would be your answer as well. Example 6, find the values for A, B, and D here. And so if we take a look, our amplitude, or our midline first is at 3. Our amplitude is at 6. So from 6 to 3 is going to be our amplitude. So here we should have f of theta equals 3 sine. Our period is pi. So 2 pi over pi is just 2 is going to be our b value. And then here it's going to be +3 because we are shifting the entire graph up 3 units there. So that would be our answer to example number 6. Example number 7, the figure shows a graph of a sinusoidal function g. What is the period and amplitude? Here, the period, let's take a look. I see a starting point at -pi/2, and the next time I see that is going to be at pi/2. So pi/2 minus -pi/2 will be the distance between them. This is then just pi/2 plus pi/2. So 2 pi/2 or pi. So our period here should be pi, so we can eliminate C and D. And then our amplitude goes from 1 all the way to our midline here at -1. So the distance between that is 2. So here A is the correct answer because it's not going to be B or D. So, all right. So for example 8, let's sketch this one out. So we know a trig function has a maximum at the point 0, 6. So let's label that there. And then we know after this maximum, the next minimum will occur at pi/2, -4. So let's label that there, pi/2, -4. Which of the following could be an expression for k? So if we take a look here, these all look similar because they all have a +1, and they all have cosine, but they have different amplitudes and different b values. So let's see if we can figure that out. Our amplitude, we go from 6 to -4, which means our midline should be at 6 plus -4 over 2, which is 2 over 2, which is 1. We also see that 1 is our only option here. So at 1 is going to be our midline. And then our amplitude is going to be from 6 to 1, which is 5 units. So 5 should be our amplitude there, C or D. And now in terms of our B value, one thing that you always need to know with these types of problems is the fact that the distance from your maximum to the minimum is half of your period. So here from 0 to pi over 2, that's only half of it. You're going to need that other half at pi to get that full period. So your period here should be from 0, not to pi over 2, but to pi for just a period of pi in this case. And then your B value should be 2 pi over pi to get 2 as your B value. So D is the correct answer for example 8. For example 9, this is a question you could see. You're given an equation. You need to match it to a graph. So here, the trig function is given by 3 sine 2x minus 1. Which of the following could be the graph? So first, let's just take it easy. See which ones have an amplitude of 3. So A has an amplitude of 2. That won't work, so we can eliminate A. B has an amplitude of 3, so that is okay. C has an amplitude of 3, and D also has an amplitude of 3. Now let's see which one has a midline at -1. B does, so B is good. C also does, and D also does as well. So that really doesn't help. Now let's see sine 2x. So if our B value is equal to 2 pi over our period, sometimes we may need to find our period. So let's multiply both things by our period. So our period equals our period times our B value equals 2 pi, and then our period equals 2 pi over our B value. So in this case, 2 pi over our B value of 2, our period should really be pi. So here, from 0 to pi, this does not complete one full rotation. It's just half of a period. So we can eliminate B. For C, from 0 to pi, this completes one full period only. So that is still in contention. And then for D, here we actually can complete 2 full periods by the time we hit from 0 to pi. So here we can eliminate D, and C should be our only answer for example number 9. All right, and now the final letter today is C. So think of C as your starting point for a sine or cosine function, depending on what the question is asking you for. And then just take the opposite of that for your C value. So remember, horizontal translations and even horizontal dilations are inverse. They do the opposite of what it looks like it should do. So here we're going to want minus C as our sine or cosine starting point there. So let's work through a few examples. Write the equation of this cosine graph in the form of cosine theta plus c. So here our cosine starting point is going to be at the max going down. This is at pi over 2 comma 1. So my equation here is going to be f of theta equals cosine and then theta. And now we want to use our x coordinate, so pi over 2. And it would typically be plus, but we're moving it pi over 2 to the right. So we are going to put theta minus pi over 2. And that's our answer for part A. Part B, here, we have our cosine starting point at, if this is pi over 2 and then 3 pi over 2, on the unit circle, this would be 5 pi over 4. So this would be f of theta equals cosine, and then theta minus 5 pi over 4. And that should be our answer to part B. So typically, if I give you a graph like that, it would be labeled enough. You wouldn't have to do that. But if you need to, just know smack dab in between pi and 3 pi over 2 on the unit circle is going to be 5 pi over 4 there. All right, so when you're solving these graphing problems, it is important to know that you will never ever be asked to graph a function by hand on the exam, but you may need to create an equation off of a set of points or find the appropriate graph to an equation or equation to a graph. And so you still need to know these characteristics. You just know you won't have to do it by hand. Like you won't have to be graded on your graphing. But because you have multiple choice, use that to your benefit, eliminate answer choices you know are wrong, and go from there. All right, so let's work through this problem together. This is one of the hardest problems I would say you would see for this section. And so the graph shows the trig function g. Which of the following could be an expression for g of x? And so let's take a look. I notice that they all have a d value of -1, so that really doesn't help. But let's see what else they have, right? They have a period of 2 pi, and they all have an amplitude of 3, and then they have different sine and cosine starting points. So let's take a look at A. A is saying we're going to start at 0. It's going to be a positive cosine value. So that should look like you're at 3 there and you're going down, which does not match with the graph, so it can't be A. For B here, we're moving the graph pi units to the right, so this is going to be our starting point, but it's negative cosine, so it should be right here going up, which this is not, so it can't be B. C and D, taking a look here, at C, we would need to do pi over 2 and then to the left. So we kind of need to extend this graph out, which is a little bit annoying. So this should be negative pi over 2. If this is pi over 2 here, this would be negative pi over 2 at the midline of -1 here. So that is our midline here. So if we just continue that, and this is at negative pi over 2. Let me erase the other one. That's a little off. Yeah. So negative pi over 2 like that. This point right here. If this was a positive sine value, so it should be, if we'll use blue here for this one, that would be at this point right here, and it would be going up, which this isn't the case, so we would eliminate C from our answer choices there. And then let's take a look at D. For D here, we're going to be moving 3 pi over 2 units to the right, and then it's a negative sign, so it's right here at 3 pi over 2 and then going downwards. This actually is the only one that aligns with the graph, so D should be our correct answer for example 11. And so now, one thing to just be aware of is when you put a phase shift and a period change, so basically values for B and C in the same equation, make sure that you have parentheses that separate it. You're going to want f of x equals A sine, and then here you want B separate, and then theta plus C plus D, where your theta plus C is kind of factored out. If it isn't, you would need to do that before you graph a trig function, but it should already be done for you. The only time you'll have it in this form is when you use a calculator, but then you won't have to deal with factoring it out. So don't worry about it. Just know that when you write your equation, you're going to want that theta plus C factored out of your parent function there. So example number 12, the figure shows the graph of trig function h. Which of the following could be an expression? So again, all have a midline of 1, all have an amplitude of 2. Let's see which one matches up with our sine and cosine starting points, because they also all have a b value of 2. So none of that really helps. We'll do what we did last time. So here, looking at A, we're going to be moving pi over 4 to the left. That's going to be right here. And then this is 2 cosine, so it's going to be positive. So that should be right there going down, which it's not, so it can't be A. Looking at B, our green value here, this is going to be pi units to the right, and it's a positive cosine. So it should be right here going down. It's not that, so we can eliminate B. Here for C, we have pi over 4, and it's going to be a sine. So that's going to be right here, and positive sign goes up. This does work, so C should be our correct answer. But let's just check D just to make sure. So for D, you're going pi units over, and it's a positive sign. So this should be right here going up, which obviously it doesn't align. So C is the correct answer there for example number 12. For example, number 13, the graph of h and its dashed midline for 2 full cycles are shown. We are given the following coordinates. So f is 2, 16, g is 5, 11, j 8, 6, k is 11, 11, and then p is 14, 16. And so we want to write this function in this form. So this should be h of t equals a sine and then b in parentheses t plus c and then plus d. So here, let's take a look. Let's knock out the easiest ones first. So our amplitude is going to go from 16 to 11. So here our amplitude should just be 5. So let's fill that in. Then we know our midline should also just be positive 11. So we can fill that one in as well. So A and D are pretty easy. Our B, our period, goes from 2 to 14. That's the length of one full period, which is 12. So then our B value should be 2 pi over 12, which should simplify to pi over 6. So let's fill that in for our B value there. That is correct. And now our horizontal translation, we want a sine graph. So our sine starting point is going to be at the midline going up. And so we are going to do t not plus 11 because we want to move it 11 units to the right. So it should be t minus 11. And that is our values there. You could also put in like a box like this and say a is 5, b is pi over 6, c is negative 11, and d is positive 11 there. Right. So if you have any other questions, please come see me in office hours, and I will see you guys later. Thanks.